ben Hans and I'm going to tell you something about our Cyber Physical Systems project. We created an autonomous riding car. It was a lot of fun to do and we had a very nice group. This is our car. There is a Raspberry Pi mounted on top of it and it is a camera to see the route. It looks very cute. The car has two motors, one to steer and one to move forward. Approximately 30 times per second, the Pi gets an image from the camera. It does some image processing to determine whether to go left, right or forward. The Pi sends a constant spray range signal to the motors, except from when it steers. In that case, it needs to send a higher signal because it needs to overcome the friction caused by the wheels standing in an angle. This is how our image processing algorithm works. First, the picture will be made black and white. Everything that is dark gray will be made black and everything that is light gray will be made white. After that, the largest white contour at the bottom of the picture will be considered the route. After that, a line is drawn through the center of this object. This line can be constructed by counting the number of pixels at the left and the right. If this line comes out of a certain threshold, the car will steer. By choosing good parameters for the threshold, we can let the car follow the route. We tested our design and it works. It can follow arbitrary routes, but they have to be wide enough. It can also not make sharp turns because of the turning radius of the car. Also, the battery pack cannot be put on the car itself because the motors cannot carry that much weight.
A lot of the previous mentioned issues can be solved using a different car. We would have liked to make our own car, but we didn't have the time for it. But if we have more time, we would definitely like to do this, because with a better car, we could make a better controller, for example a PID controller. With a better car, it would also be able to ride without wires, because the car could actually carry the weight of the batteries. We would also have liked to implement avoiding obstacles. Right now, if there's an obstacle on the road, it will turn, but it will still run into the side because the car is just way too large to actually avoid it, and the camera is in the middle of the car and cannot detect how far it has to go. That's not ideal. Another thing that we would have liked to implement is a proximity sensor to actually see obstacles in front of you, so that even if the camera would not see it, you would not run into it, which gives fault tolerance. Another thing we would like to add is sensors on the side of the car that would detect the edge of the road without using the camera, so that the car can never go off the road. And that's also a really good example of fault tolerance.
The project was a nice thing to do. It was a good mix of hardware and software challenges. Actually, this one module has a good mix of these challenges, and that makes it a very nice module to do.